tree diagrams in probability. So when you're studying probability, the introduction to probability, you're going to run into these tree diagrams. They're super useful. It is just simply trying to find out, what all the possible outcomes are when you're kind of creating pretty much theoretically, some kind of a theoretical experiment. So for instance, I'll give you, a couple of examples in here just so that you get a sense of what these tree diagrams are all about. So let's imagine that, you're flipping a coin, right? If you only flipped a coin one time, I'm assuming we're having a good coin, which is, not fudged in any way. So you would have either a heads or a tail, right? Because that's the two possible outcomes that could happen. And that's not a big deal, right? So, you can say, okay, so we have a heads or a tail that might happen when we're going to be flipping a coin, okay? And you would say, okay, so these are the outcomes that we have. And that would have been just one flip. But what if someone says, well, what if you wanted to flip 2 times? What are all the possible outcomes, okay, if you flipped 2 times? And you would say, oh, okay, well, I guess I can still write that out. You can get a head and a head, a head and a tail, right? You can get that. You can get a tail and a head, okay, and then a tail and a tail, okay? So still not bad, right? But if you now flip it 3 times, or let's say maybe 4 times, it starts to get annoying to try to find out what all the possible outcomes are. And this is where these tree diagrams are kind of useful. So, let me show you. Let's say for 3 flips of a coin, how would we get all of these possible outcomes, okay, that we would gather? So if we flip it once, we know that we're going to either get a heads, okay, or a tail, right? So this would have been kind of the first coin flip that you could get. Now, if you flip it 2 times, you would get a head and a tail here, okay, and a head and a tail here. And these, okay, each path on the tree will just simply create, okay, the possible outcome. So that would have been my first one. Here, if I went this way, okay, this would have been my heads and the tail. And then I think you get the gist, right? So you can just keep kind of going. Now, if you continue with these flips, you can say, okay, well, I can get a heads or a tail here, heads or a tail here, heads or a tail here, and then heads or a tail here. So now what you've done is, okay, you can actually count up, okay, well, what are all the possibilities? You can certainly list them for yourself because you can see what is happening. So this would have been, head, head, and a head. The second one would have been a head, and a tail. And then you can list all of these, and you can see that you have 1, 2, 3, 4, 5, 6, 7, okay, 8 possibilities. Now, how many possibilities you have, you don't have to do a tree diagram for yourself. The tree diagram is more so that it pops out at you and you can see. If you've done, for instance, combinations, and in terms of counting things, then you know that, you could have just as easily created this by saying that, okay, well, I have 3 flips. I'm going to either get a heads or a tail. So those are 2 possible outcomes, right? So we're going to be using the multiplicative principle, On the second one, you're either going to get a heads or a tail again, and on the third one, you're going to get heads on a tail, and then you have your 8 outcomes. But the tree diagram is more so that you can actually see, right, the outcomes, you can write them down, and you can get a feel for them. This doesn't, of course, just apply to heads or tails, but it applies to anything, okay, where you have, or you are repeating, multiple things, okay, numerous times. If you're only doing it once, like, flipping a coin, the tree diagram is not really very useful. But if you do it 2 times, 3 times, it becomes more useful. Now, if you do it too many times, then it becomes super cluttered, and a tree diagram may not also help you too much, right? So, where else can you do this? Well, you can certainly do it with, tossing a die. So if you have a die, you can have a result of a 1, 2, a 3, a 4, a 5, or a 6, right? So that would have been on your first kind of roll of a die. And then from here, you will notice that from each one, you will also have now a 1, a 2, a 3, a 4, a 5, or a 6. So, your tree diagram from each point, okay, would have this. And now you see that, oh, well, this is going to be a little bit hard to try to draw out, okay? Because indeed, if I wanted to now take it and expand the tree diagram from the 2, I'm probably going to be moving this down a bit just so that it doesn't get complicated. And then I would repeat this process here. Okay, I'm going to duplicate it so that it just does the 2. And then I can continue with the 3 and 4 and 5 and 6. So the tree diagrams are nice and useful, but as you can see with rolling a die, well, if you start writing them out, it becomes a little bit problematic, right? So there might be a better way, okay? Maybe you can write out, a table where you have one roll and then a second roll on the top, okay, so that you can see it. Now, for these tree diagrams that you will see, you certainly do use them in probabilities because they give you the total outcomes, and then you can count, for instance, maybe an event that you're interested in, right? So maybe the event, okay, was, if you're going to be rolling or flipping a coin, what's the probability of having, 2 heads, okay, in 3 of those possibilities? Well, now, once you see that you do have all the different possibilities, seeing that you have, 2 heads, you can actually write down how often that happens, divided by 8, okay, if it was with 3 tosses, okay, that you were doing it. So those tree diagrams become useful for that. I'm not going to say much more in here because I think these tree diagrams become self-explanatory to try to show you, first kind of, trial, and the second trial, third trial that you may have as you're going through to be able to see what happens. All right. Thanks for watching, and we'll see you in a future video. Bye, everybody.